So this is Leetcode number 994, that is routing oranges. And so what we have to do in this question, so we have given m cross n grid there, and each of the cell represents the value of, there's the three possibilities there, either 0, either 1, either 2. And what is the meaning of this? 0 means there's no there's an empty cell, or we can say there's no oranges there found there. 1 means there's a fresh orange, and 2 means there's a rotten orange. So what we have to do, we see in this question, this is given that every minute each of the fresh orange, it has to rot is like a, let's say if I'm talking about this grid, so there contains some of the fresh and some contains some of the rotten. Okay, so like what is the issue with this? So if in this question it is given as like it takes 1 minute to rot all of the oranges that are just adjacent to it. Or what's the meaning of adjacency? Like we have to see this in 4 directional adjacency. Let's say if I'm talking about this, so there's not any of the oranges are on its top part or left part, but right and below is available there. So we can say in after t is equal to 1 minute, it has to rot this orange and this orange simultaneously, and like this chain goes on and till this rot all of the available if they are connected or not. Okay, so like we have to return so like how many of the minimum time it required to rot all of the oranges, and if that the case is falling in which it is not able to rot all of the oranges, so in that case we have to return -1. Let's say if I am talking about this to wait a second, let's discuss here. So I'm explaining this part, like how to do this. See, there's a 2 1 1 0 1 1 1 0 1. I think this is not given in this example there, so I have to explain this further. Okay, if I'm taking that part here, so see here. Okay, so like what's the meaning of this? This is nothing but the 2 1 1. So this is mean this is a rotated part there, and there is one oranges. Okay, there is one again orange there, there's empty, there is one orange, there is one orange, and there's again empty, and there's wait a second. Okay, there is orange there, there's empty, and there's orange. Okay, so this is the case shown in here. Okay, so if we are starting from from where we have to start this, simply we have to check from why it returns -1 there. Okay, so now if you have to see there, it is rotated. Okay, so and all of the remaining oranges are the fresh. Okay, so we have to start from this. So at t is equal to 1 minute, it has to rot in this part. Okay, so it means it become rotated. Okay, it become rot there. After it has to rot on its adjacency, since it is already, so its adjacency is this orange, so it become rot there, and it become rot there. Okay, so we can say t equal to 1 minute, it has to rot, it takes to rot this, and t is equal to 2 minutes, it simultaneously returns to both these two. We can say these two. Okay, so till here the times taken is t to equal to 2 minutes. Okay, now further see, we have to see there how many of the oranges it has to able to rot this. So there's no oranges present there, there's no oranges, it is already, so there's only possibility that it has to rot this. Okay, so it means it become rot. Okay, so it takes time 3 minutes. Okay, t1 for this, t2 for rot for this, and t3 for this. Okay, now see for this, there's no oranges present at here and here, and it is already done by this. Okay, so like it is not able to rot any of this. Okay, now come to this, so there's right no possible, upper part it already, left part already, down part there's a fresh, so it has to rot this, so it takes t equal to 4 minutes. Okay, now so we say here one thing, that we have to rot all of the oranges. Now if you have to talking about this, there's a left not oranges present there, down not present, right not present, upper is already present there. Okay, so it means this chain is extend there, or this chain is complete there. But we see, if I have to traverse all of the thing, there is a one of the fresh oranges remaining there. Okay, so in that case we can say this is not possible to rot all of the oranges, so that's why we have to say this is nothing but the return to -1, because we are not able to rot all of the oranges, and if we are able, so we have to return the minimum time there. Okay, So now come to the intuition part, like what's the given in the question there. So like you know very well, like this is very this is graph questions. These are the doing either by DFS or BFS, depending on the whatever the question demands. You have to do this part. Okay, we can say one thing, that every step we want to spread our road from already rotten oranges to our adjacent. So what we can say, if we are standing at one rotating position there, let's say if I am representing this by rotating position, so it has to spread in 4 direction. What are these 4 direction? These are these 4 direction there. Okay, so we can say, since all of the rotten oranges spread simultaneously, so we can say this is not we can say, since all are rotten in the simultaneously, so this is not the simple BFS here. This is not simple BFS, it is nothing but it is multi-source BFS there. Why it is multi-source BFS? Because at the same time it has to route the all of the 4 directional adjacency. So it has to, we have to apply BFS in all of the 4 direction. Okay, and like this is, and let's say if I have to, like when I'm make this as a rotten there, this as a rotten there, and this as a rotten there. Okay, and this as a rotten there. Since we have to find the minimum time, so what we need to, we have to do the rotten process continue from the all of the rotten oranges simultaneously. So that's why we have to apply BFS from here, BFS from here, BFS from here. Okay, so that's why it is nothing but the multi-source BFS. Okay, so that's why it is multi-source BFS, not the simple BFS. Okay, so like what we need to so first of all we need the, we can say, the minimum time there. Okay, because it is asked in the question, and we can say, since spreading is happen in level by level, and each level we can say, each level is nothing but the, it is nothing but the 1 minute there. Okay, so this is given in the question there. So that's why we have to see, like this is the intuition, that's why we go for the BFS part, because BFS is nothing but the level traverse order. So because we have to finding this is approaching in the 4 directions, so that's why so whenever let's say we can say at one time it has to route its adjacent. Okay, so that gives me the minimum time there. Okay, so like what we have to do, simple. So in this BFS question, this is the one standard thing that what we have to do there. Let's say if I have to write the steps here, push the whatever our step there. First of all, we have to push our all of the rotten oranges into, we can say, the queue part there. Okay, because this is a multi-source, so that's why we have to initiate from all of this simultaneously. So that's why push all of the rotten oranges into our queue. After it, we can check what are our fresh oranges at initially. Why it is needed? Because to handle the test cases like this, in which the, let's check in the final whether any of the orange is remaining the fresh or not. Okay, so that's why we take the counting at initially. Okay, now what we have to do, simply start our BFS there. After it, we can say for each of the level we have to do, we can say for each of the level we have to spread to adjacent part. Okay, spread to adjacent and convert them into rotten part, there. Okay, and so after it, or we can say, so by this our fresh count frequencies reduces. Okay, and after it we have to track what is the maximum time there. So don't confuse it by like in the question it is asking about the minimum time, but we are using maximum time there. See, this is asking me what are the minimum time to route the all of the oranges there, and this is maximum is nothing but that this gives me the time at each of, like in each cycle it takes let's say one time there, time 2 there, time 3 there, but we have to count all of that. So that's why we have to count what is the total time there. So that's why we have to track the maximum time there. Okay, after it, or we can say if our any of the we can say if fresh remains there, so in that case simply return -1 there. Okay, so that is the nothing but our question there. Okay, so like what are the things, and like when we have to store our queue, so what are the things we have to store in our queue there. This is nothing but the, let's start from it here, this is nothing but the row comma column. Okay, so this gives me the coordinate there, and after it we can take the time part also here. because that gives me the final time there. So this helps me to track the what are the position and time at which it becomes the rotation there. Okay, now we can we know one thing that in this question there, let's say we are standing at the R comma C position there. Okay, so from it we have to move in the 4 directions, and if our neighbor is fresh, make it rotate and push in Q with increment or with updated time as time plus 1 there. Okay, because it takes extra time 1 unit there, so that's why. Okay, so okay, so this is the question, and come to the part there, come to the coding part there. See, first of all, this is our vector grid there given, so I initialize the size as nm. This is one column there. I had to use a visited vector here to so that it doesn't go in the loop. If it has to let's say if it has to rotate one orange there. Okay, so now don't has to calculate this again and again. So to avoid that part, we have to track what are the unvisited or what are the visited states there. So that's why we are using visited vector array. There is one q vector array that's track x comma y comma t there. Okay, now we can either use a fresh count there, but okay, so like I explain you by both method. I have to traverse simply and check what are the oranges are rotten. Simply push this in our queue and make them as visited, because we don't want to visit them again. Okay, so that's why initialize our time as 0. These are the 4 direction, like how to do this, I think like I already explained in my previous videos. Because if I am standing at R comma C, so what are the possible conditions to go in the 4 direction? This is nothing but the, if I have to start from here, so this is nothing but the R comma column plus 1 there, column plus 1 there. Okay, and similarly this is nothing but the R plus 1 comma column there, and this is nothing but the R comma column minus 1, and this is nothing but the R minus 1 comma column. Okay, so these are the things. So that's why I have to store the 0 comma 1 comma 0 comma minus 1. So that's why you have to take the dx vector, dy vector there. Now what we have to, this is simple traditional template of our BFS. While the queues become empty, first extract this row, its x coordinate, y coordinate, and the time, and element this part, and this gives me the total. This time is our required answer. So every time at every level we have to use the maximum update this part. Okay, and what we can see here, for all of the 4 directions there, you have to make update this as nr. This is become nc. Checking for the valid condition is greater than equal to 0, less than m, greater than 0, less than m. Okay, and if is v of nr and nc is equal to 1, because this gives me the fresh condition. Okay, so if they are the these are the condition not violating not violate any of the conditions such that it exceed in the grid there, and it has a fresh orange available there, and it is not visited. So only in that case, first we make it visit, then push in our queue, and what are the nr nc coordinate, and time will update as t plus 1. Okay, so this gives me, so that gives me the total time there. Now see the one condition, now check those are the conditions in which any of the fresh count left or not. Okay, so what we can say, we simply traverse I 0 to n and 0 to m and check if any of the fresh there and that is not visited, it means it is not rotten during this process there. So that's why I written -1, and in that case, in the case if not any of the fresh is left there, simple return the time. Okay, so this is our simple code there, and what is the time complexity it is given there. So it takes simply n into m and space complexity n into m again there, because we can say n into m for this part, and in the worst case it has to go for the all of the store of the node. So for each of the nodes there's the 4 directions, so actually it takes the 4 into n into m, but that takes approximately n into m become. Okay, you can avoid that part also, avoid this again traversing. We can use one fresh count there so as to avoid this part there. Let's say what I'm trying to say, let's say I have to initialize our int fresh. We can say, wait a second, this is nothing but the int fresh is equal to 0 there. Okay, so what I'm trying to say, if I initialize our we track our cases in which case if our v of I of j is equal to 1 there. Okay, so by this we have to update our fresh there, so that becomes nothing but the fresh plus plus. Okay, and what we have to do here, after calculating in the this our q part there, we can check if this condition will become the valid there. So in that condition, what we have to do there, wait a second here, okay, so what we have to do there, if our 4k is equal to 0 to 4, so if that condition is matching, means it doesn't violating any of the property there and it has a fresh there and it is not visited, so in that case make the visit. And also what we have to do, simply fresh minus minus there. Okay, so that gives me the again the thing there. And at last we have to check simply that if our fresh is nothing, it is greater than 0, means simply return -1, and if it is not the case, so simply return the time there. Okay, so avoid, we can comment that part there. Okay, so this can also be the question there. This is the simplified version, we don't have to traverse again and into m loop for here also. Okay, and coming to the space complexity, we are using the q extra q there and vector there and into m, so that's why space complexity become n to m. So that's the question here.